This Gd&T project will cover a secondary keyway shaft and a dyno collar for CVT testing. So this is the part we chose. It's a secondary shaft with a keyway and a key that fits inside of an adapter or a collar for CVT testing on a dyno. These are the three components that make up that shaft. There's the collar or the adapter, the shaft with the keyway, and then the key itself. So the form of these two things has to be really similar. They both have to be circular, as seen on the left, with the shaft in red fitting through the bore of the collar. Although you can fit more of a rectangular or a square shaft inside that same bore, you wouldn't get enough interface with the walls for a secure fit. So the dimensions called out here, C, the datum, is the axis that runs the length of the shaft, and then D is the perpendicular axis up to 0.002 inch tolerance with relation to C. And then the mating feature, this cross section of the shaft with the keyway with 0.002 inch with relation to C and then D. Similarly, on the collar, datum A is the axis that runs through the center of the bore, and feature B is perpendicular to that within 0.002 inch. And then the mating features seen above on the right and below on the right would incorporate the key called out in the drawing for secure fit that prevents rotation.
Size of mating features. First off, we approach the inner and outer diameters of both the shaft and the collar. We decided to go with an LT6 locational fit. This is recommended for electric motors on shafts. You can see from our tolerances, in an MMC state, this would cause for a slight interference, which we think would be useful for the torque application of this part. Next up was the dimensioning of the key itself and the keyways. This was important because you want the biggest key to always fit in the smallest hole. So in the MMC state, you can see on the right, we've illustrated the biggest key and it's fitting in the smallest keyway. Horizontally, this is pretty easy to do, but vertically, we got a little bit of a tolerance stack up that you have to be aware of.
Orientation. The shaft will have the key perpendicular to it on the first indent shown here on the left side. With that, this part will slide over the shaft and key with the indent in the middle, fitting the key in between.
Location. Along with orientation, the location of the parts both have the same center location, and all x-axis centers are aligned on the shaft, collar, and key. All locations of the parts are defined by the orientation that was previously discussed.